Hi, this lesson provides a quick introduction to sensing circuits. Before we take a look at the sensing circuits, let us first understand how a transistor works and how it is used in the sensing circuits. A transistor is an automatic switch. Instead of pushing a button to turn it on, it has a contact called the base that controls it. With no current flowing into the base, the transistor is switched off. When a small current flows into the base, the transistor switches on, allowing current to flow between the collector and the emitter contacts. If you plan to include a transistor in your design, it is important to know that a very small current flowing into the base of a transistor is enough to switch it on, and a much larger current is able to flow between the collector and the emitter. You may also like to know that the base of the transistor is usually connected to a sensor. If the sensor allows enough current to flow, the transistor switches on. A resistor is usually connected to the base to prevent the transistor from being damaged by too much current. Water sensing circuits are useful in various situations like checking the dampness of soil for a potted plant, raising an alarm when it rains, and so on. A simple moisture sensor can be made with two metal rods held in connecting block. It is connected to the base of the transistor. In dry conditions, no current flows into the base of the transistor, so there is no output. In damp conditions, a current flows into the base of the transistor, and so your output will be triggered. Temperature sensing circuits have many applications. They are used in products such as electric kettles that switch off automatically, electronic thermometers, and so on. Temperature sensing circuits uses a component called the thermistor. The thermistor is connected to the base of the transistor. In cool conditions, resistance is high, no current flows into the base of the transistor, so again there will be no output. In warm conditions, resistance is low, so current is able to flow into the base of the transistor and the output will be activated. Many products use light sensing circuits. For example, lamps that switch on automatically in the dark, cameras with light meters, alarms that go off when a beam of light is broken, and so on. Light sensing circuit uses a component called a light-dependent resistor. Once again, the light-dependent resistor, or in short the LDR, is connected to the base of the transistor. Okay, let us take a closer look at how a light-dependent resistor works. In dark conditions, resistance is high, so no current flows into the base of the transistor, and therefore your bulb will not light up. In light conditions, resistance is low. Current flows into the base of the transistor, and therefore your bulb will be switched on.